Hi class, this is Professor Teixeira. In this video, I'm going to talk about safety stock and service levels. Safety stocks help to protect company sales from demand uncertainty and also helps to protect raw material and components from lead time uncertainty from the supplier side. So it's two sides. One is uncertainty in the lead time from the suppliers and suppliers' deliveries, and the other one is demand uncertainty because there are more consumption. The safety stock is determined by this formula, which has a Z value. This Z value is associated with the customer service level or the service level the company wants to provide. The service level is what percentage of the variability in this demand the company wants to match. That's the service level. So from all variability possible, the company wants to match 95% of the all potential variability. That's the service level. If the company wants to match 98% of all variability, that's the service level. Okay, and this service level is based on like a policy that the company determines. The company wants to protect this variability in sales, in the demand. Here there is a chart just to illustrate that the safety stock is this 50 units at the bottom, and again serves to protect against uncertainty. This is a inventory level, 500 units, and then demand is consuming, let's say finished goods, and demand is consuming, the demand is higher than the average. So because the demand is higher than the average, when the company places a new order in this reorder point, this is the reorder point, when the inventory goes down by sales and reach 250 units, the company calls supplier and asks for a new shipment of 400 units. That's the optimal queue. But until the shipment comes, the demand's still like consuming the finished goods. People are buying, and then the inventory keeps going down, and the shipment hasn't come yet. And sometimes you can reach the safety stock, and the safety stock is there as a buffer to protect the company. So the company has finished goods for sale to match the demand while the shipments come. When the shipment comes, we have a replenishment of units, 400 units, and then the inventory goes up. And then again, demand keeps coming, people buying, but this time the demand is less than the average. So when it reaches 250 units, the inventory reached 250 units, the company places a new order to the supplier and wait for the shipment to come. But this time the demand is not too high. There is some consumption of the finished goods, but at this time it doesn't reach the safety stock. When the shipment comes, there is still a lot of inventory, not even the safety stock was used. And then 400 units more replenishes the inventory. So let's say if here is about 120, 100 and maybe 50 units, plus 400 units goes to 500 and something. Okay. And then this time demand equals average is perfect demand and the average. And then when almost get to touch the safety stock, a new replenishment. So these are examples of how the safety stock can be used to protect. Sometimes it's going to be used, sometimes it's not, because demand varies. Okay, so that's what it is. And to complete the safety stock, we need to know the customer service or the service level, which is a policy of how percentage of this demand variability that the company wants to match. We're going to use this percentage, in this case, for example, 95%, and then we're going to find a Z value for the standard normal distribution. In this case, is 1.645, and then we're going to enter in this formula and multiply by the standard deviation of demand during the lead time. And the reorder point is going to be the demand during the lead time plus safety stock. Let's take a look at the problem to see how it is. Okay, suppose that the owner of the campus bar Nix has determined that demand for beer during the lead time averages 5,000 bottles. So we have information here that demand during the lead time, let's do DL, demand during the lead time is 5,000 bottles of beer. What else? Nick, the owner believes the demand during the lead time can be described by a normal distribution with a mean of 5,000 bottles and a standard deviation of 300. We already have the average. Now the sigma for the demand during the lead time, which is 300 bottles. Okay, Nick is willing to accept a stockout risk of approximately 4%. The stockout risk, put here, stockout is 0.04 or 4%, right? And that's the opposite of the service level. That's the complement of the service level to 100. So if the stockout is 4%, what is missing to 100 is 96. So my service level here is, let's do equal 1, which is 100 minus 0.04, 4%. So the service level is 96%. Okay? All right. So we have to find the Z. What is the Z associated with a service level of 96%? The Z is a standard normal value from the standard normal distribution. And to find it, we use the function equal. We type in Excel equal norm dot s dot inv, and then we type the probability 0.96 close parentheses. Or you type or you select the cell. The Z value is 1.75. I can reduce the decimal places to make it like easy to see. So my safety stock, now I have the Z, I have the sigma, the standard deviation during the lead time. So my safety stock is going to be 1.75 times the sigma or the standard deviation during the lead time, which is 525 bottles of beer. Okay, so that's how much I have to carry a safety stock. This is how many beers. Now let's do this. The bar has to carry 525 bottles of beer in the safety stock to provide a 96% service level, meaning they will, let's say, protect sales, or they will sell if the variability goes up. Let's say there's so much variability, meaning that they will sell if the variability reaches the point of, let's say, 96% of whole variability. I'm going to show you, okay? So what I'm trying to say here is that the bar has to carry 525 bottles of beer in order to protect the variability in the demand. So this variability is not 100%. He's willing to accept a stock out of 4%. So he's protecting if the demand goes too high. 96% of the entire possible variability. Okay, so the reorder point is equal to my demand during the lead time plus the safety stock. So that's my reorder point. When the inventory reaches 5,525 bottles, they place a new order. They place a new order for more beers. Okay, so let's take a look here. To determine to find the z-value, we use this formula like I did. The solution is that the z value associated with 96% is 1.75. The safety stock is 525 bottles of beer for the safety stock, and the reorder point is the demand during the lead time plus safety stock 5,525 bottles. I have this chart here to help you understand and illustrate what we mean by that. Here is the average 5,000 bottles. So that's the average amount they sell. However, they don't sell the average every day. Some days they sell less, sometimes they sell more for different reasons. We don't know. Sometimes we can know, but it doesn't matter now. It varies. Sometimes people buy less, sometimes people buy more. When people buy more beers, that's what the service level is trying to match, protect in terms of sales. So if the demand goes up to 5,500 bottles of beer in a given day, they have enough stock, they have enough inventory to match the demand. How much they can match the demand? If you see, is 5,525. So that's what they can provide in terms of service level. If the demand varies as much as this amount, they still can sell. If there are more sales, if a given day there are 5,550 people coming up to buy one bottle of beer, then they don't have enough. So they're going to stock out a little. They're going to stock on, in this case, 25 bottles. Because remember, the full inventory is 5,525. I'm hypothesizing 5,550 people. So 25 is going to stock out. And that's what they accept, that they accept the risk of stocking out a certain amount. This is the amount they're accepting to stock out. This plus this, in fact, this in top represents 2%, the other 2%, with together is 4%. Okay, and this entire area is 96%. Of course, if it is below 4,000 and something here, they will have enough to protect. What they don't have is when the demand exceeds that variability. Okay, so that's it for this safety stock issue.